It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee.
Hi guys, welcome to this video, which is going to be all about biofuels, which is one of the new things in the new SACE curriculum this year in 2018. So hopefully you get a bit of an understanding. It probably won't be too long. It's just going to go through what biofuels are and how we produce them. So a biofuel is a fuel which is made from organic material, so biologically or occurring material, so dead plants are probably quite commonly the things that we use. There's two types of biofuels we're going to be looking at in stage 2, and one of them is bioethanol, okay, and the other one we're going to be looking at is biodiesel, okay. So what we're going to be looking at in both of these is replacements to common fuels that we use in our cars at the moment and how we create them. So I'm going to start off by working on bioethanol firstly. So bioethanol is normally produced from corn, okay, that's one of the main crops that we grow, and what we get from corn is what we call complex carbohydrates. So they have this formula sort of CXH2OY. So they're big, long chain molecules, okay, made up of carbon, hydrogen and oxygen. What we do is we hydrolyze them. Now hydrolyzing simply means that we're adding in water, and those get broken down into what we call disaccharides. Okay, so a really good example is C12H22O11. Okay, that's a disaccharide. What we do is we hydrolyze it again, and this is where we break it down into what we call simple sugars. Okay, so C6H12O6. Okay, so glucose is the most common form of simple sugar that you'll find. They're sometimes called monosaccharides as well, or one sugars. Okay, and this glucose here, this simple sugar, is what we use to create our bioethanol, and we do that via a process which is basically like a fermentation. Now, fermentation is a process that has been around for thousands of years, which is how they produce ethanol from sugar. Okay, and so what you've got is you've got your glucose here, C6H12O6. Okay, and in the presence of an enzyme, which is just a biological catalyst. Okay, normally the one they use for when we're doing a bioethanol is one called zymase. Okay, but it's just a biological catalyst that breaks down to produce ethanol, C2H5OH, and we get some carbon dioxide produced as well. Okay, so this is the process of producing ethanol here from biological material, in which case it came from corn originally, and we've got our simple sugar. What they then do is some distillation, okay, because this ethanol that you get out from here will probably be around about 14% ethanol. We want to have a higher concentration than that to be able to use. So what they will do is do some distillation, and that distillation will produce a much higher concentration of our ethanol. What we can then do is use the ethanol as a fuel. So if you're burning ethanol, C2H5OH, all right, you combine that with oxygen. We need 3 moles of oxygen, and that gives us 2 moles of carbon dioxide gas, and we get some 3 moles of water in there as well. It's an exothermic reaction because it's combustion, releases a fair amount of energy, okay, and it tends to burn reasonably cleanly, all right, so we don't get as much incomplete combustion occurring in those products which are obviously undesirable. So that's the production of bioethanol. Now, as we said, the main thing that they come from is corn, okay. Now, the benefit of that is that the corn, as it's growing, will absorb carbon dioxide from the atmosphere. Okay, so I'm going to just show you why that's a benefit, okay, versus a normal fossil fuel. So the benefit is that we've got CO2, which is in the atmosphere, and what happens is that CO2 in the atmosphere gets absorbed by the corn as it grows, okay, to form our glucose, or our complex carbohydrate, but we convert into glucose. What we do is we convert that into ethanol, okay, so that gets converted into ethanol, C2H5OH. We burn that, and that releases the carbon dioxide back into the atmosphere, okay. But the benefit is that obviously as we grow more corn to produce more bioethanol, we absorb more carbon dioxide from the atmosphere. So we're kind of offsetting the combustion carbon dioxide that we produce. With a traditional fossil fuel, all we're doing is we're burning the fossil fuel and releasing carbon dioxide into the air. And that carbon dioxide doesn't then get reconverted back into a fossil fuel. So it's very environmentally friendly to be able to produce a biofuel such as ethanol from corn. The major downside of that is obviously we're using corn as a fuel source rather than as a food source. So number one, we're taking up land that could be used for food production, and number two, we're taking out a food source. And in the current day and age where we've got food shortages around the world and the food supply is not getting where it needs to be, anywhere which we take out the ability to grow food and produce food for the world could be an issue. So that's some of the ethical dilemmas around the use of things like corn as a fuel. So what we're going to do is just quickly look at biodiesels. Biodiesels are a little bit different. They're much bigger chains. They consist of an ester group as opposed to just a very simple carbon alcohol here. So I'll just show you how we form those. So what I'm going to look at is just how you make biodiesels. And the biodiesel again comes from an organic source, but the one I'm going to be focusing on particularly is not corn, but actually a soybean. Okay, so a soybean is what we get soy milk from. Okay, and excuse me. What we do this time is we take the fatty acid that is present within soybeans and we react that with ethanol. Okay, so a fatty acid is one that's normally between 12 to 20 carbon atoms long and contains a carboxylic acid group. So the one that we get from soybean is this one, C17H35COOH. Okay, so it's a very long carbon chain molecule. Okay, it will be water insoluble. It's very much like an oil in some sense, except that this, instead of just being a hydrocarbon, you've got a carboxylic acid group. So you've got a little bit of polarity in there, and that allows you also to react it with other things. So what I'm going to do is we're going to react that with ethanol, which is what we were just looking at before. Okay, and when you add your ethanol to your fatty acid, you get a long chain ester. It's a little bit like the triglyceride reaction, which you may look at in the organic section, but instead of using propan 1,2,3 triol, we're just using one alcohol here. So we're just getting a single chain ester. And so what we end up with is C17H35COO. So that's from the fatty acid part. That combines up with the chain part from the alcohol, so CH2CH3, and we get water as a byproduct as well. And this here is our biodiesel. Okay, much bigger chain structure than the ethanol we were looking at burning. More carbon atoms means more stored energy, so you can get a lot more energy out of a biodiesel, which is why diesel fuel is used for things like trucks and buses. You need more energy, bigger engines, and this is a really good substitute to normal long chain hydrocarbons which are used as a diesel. Again, it's a biofuel because it comes from organic material such as a soybean. All the same benefits of that we have with a bioethanol, in that terms of the soybean absorbs carbon dioxide from the atmosphere when it grows, which offsets when we burn our biodiesel the carbon dioxide we produce. But again, because we're using them as a food source, as a fuel source, they're not able to be used as a fuel source. But again, the issue is because we are using them as a fuel source, we can't actually use them as a food supply. Okay, and so that's again going to cause issues. So that's really all you need to know about biofuels. They're fuels that are created from organic matter. Okay, the two you need to know about in year 12 are bioethanol and biodiesel. I've had a look at the equations for their formations. Make sure you know how to write those equations, and make sure you know the benefits and the disadvantages of them. As always, if you've got any questions, just ask. Thanks, guys.